So let's look at the Momentum and Collisions lab. In this lab, we will look at 3 different types of collisions. Well, technically 2 collisions and 1 explosive reaction. In these collisions, we will utilize 2 cards, one red and one blue. You will have velocity time graphs for the reactions. So you will have velocity time graphs of both the red and blue cards involved in these collisions. Something you should consider is which way these cards are oriented. One end of a card actually has magnets on it, and the other end has Velcro and a plunger which can be pushed to simulate an explosive reaction. As such, sometimes one of these cards can be backwards during our experiment. So in this case, our red card has a positive end here of its motion sensor, and the blue card is oriented backwards, negative is here. This means if we were to do this experiment, we may get negative data from our blue card even though it's moving in the positive x direction. And this is something you should seriously consider when looking at the velocity time data for these particular experiments. Which way round do you think the card was? And this can be seen in these particular PowerPoints. So in the case of an elastic collision, it's really a contactless collision, because what we're going to do is set the red card moving with some initial velocity. It's going to impact the blue card. However, the impact will occur between 2 repelling magnetic systems. Therefore, there won't be any actual contact, as in the cards will not hit one another, because that would result in loss of energy due to friction and sound. Consequently, if we give an initial velocity to our red cart, it will hit the blue cart and translate momentum to it, allowing it to move. Again, think about the signs that you'll get for the velocities of the red and blue cart respectively when looking at and interpreting your dataset. Here's a video of the actual experiment being conducted. As you can see, the red cart hits the blue, and the blue is translated along the track. You can see that the blue cart hits the end of the track and bounces back. That might result in a velocity at the very end of your dataset in the opposite direction. Any artifacts like that should be ignored and or removed from your dataset during your analysis. Our second case is an inelastic collision. In this case, our carts will collide and stick together, meaning that we have 2 discrete bodies, a red and a blue, before our collision, and one body as the carts are stuck together after the collision. Now, our Velcro tabs, which adhere these 2 carts together after the collision, are at one particular end of the cart. This means the carts have been turned around. So now our red cart will be moving in a negative direction and our blue cart will be moving in a positive direction in your dataset. And here's what will happen. The red cart will impact the blue and the 2 will move together with some common velocity after the collision. So the blue cart stands still, the red cart is given an initial velocity and then moves along as one body with the blue cart until it hits the end of the track. Again, there may be some artifacts or presence in the data at the very end when the 2 carts hit the end of the track. Our final case is an explosive reaction. This means sudden kinetic energy is given in opposite directions to this system. This is achieved by a plunger that is on the end of these carts. And as anyone who has used these carts knows, these plungers go off very, very easily during a whole host of other experiments when you don't want them to do this. But here, we're actually going to use these plungers, these pistons that blow out of the sides of the cart. So by pressing a button on the red cart, this will eject a piston which will push the 2 carts apart, giving them a sudden amount of kinetic energy, a sudden impulse, and giving them a velocity in opposite directions. Think about which directions these carts will go and what you should see in terms of the sign of their movement. As in this case, both carts will be moving in their relative positive directions. This reaction, this explosive collision, is a little more violent than the other two that we've looked at. And as you could see from this little simulation, the carts bounce off the ends of the track, and you may see that in your data. So be careful how you interpret your data set. So by pressing the plunger, the two plungers release, and as you can see, the carts move, bounce off the ends of the track, and then once again bounce off one another. All we really care about in this particular case is that initial case where the plunger is released and the two carts move away from one another. So, when you're quantifying your motion, you will have to plot VT graphs, velocity versus time graphs, for both the blue and the red carts. These will often in the sheets be referred to as VA and VB. Think about the form of each of these graphs, what they look like, what this represents, and how the system was behaving. For each case, you will have to look at momentum, P equals mv for each of the carts, and how momentum was distributed between the two carts in the system before and after each of the collisions. You will also have to determine the kinetic energy, half mv squared for the system, and look at that distribution both again before and after collisions. And analyse the motion and really talk about conservation of momentum and kinetic energy in each case. Remember, we're talking about the momentum just before the collision. So what's the momentum or kinetic energy of the red cart just before it hits the blue? What's the momentum or kinetic energy after they start to move? Of course, they will come to zero right at the very end. That's not what we're looking for. We're looking for what happens right after their collision.